All right, welcome back. It is now Thursday. I hope you had an amazing night. You should have already taken your homework quiz, the daily homework check, over Unit 5, Lesson 1, and Lesson 3. And I'm hoping that it was all real easy. Now we're looking at this screen right here. This is where we left off the notes last time, so we are going to go ahead and continue from where we left off. So, on your marks, get set, yay notes! So right here we have a picture of an eclipse. You can see the sun, you can see the earth, you can see the moon. You can see where the moon's going down and coming back up. So as you notice, the moon is not in a straight line with the sun and earth. And we had talked about this before, and I know you've already read about this, but I just wanted to show you this image. The moon is not actually going to be in the same exact plane. So that's why we don't have eclipses all that often. It's actually pretty rare when they do. So it's actually rare when they do line up enough to where you get that eclipse, either the solar or the lunar eclipse. So right here is a picture of a solar eclipse. And these are the most rare of the eclipses. So when I'm looking at this, what I'm going to look at is where the shadow actually falls on Earth. So I can actually see this, and we have an umbra, we have a penumbra, and the path of totality. So there's three good vocab words from this top picture that we need to know. So the umbra is where the shadow is complete. There's no sun coming through. The penumbra is where there's a little bit of shadow, but it's not all the way. So that's kind of this hazy part right there. And the path of totality, that is where the earth is completely under the umbra, or completely under the shadow. All right. Hopefully you don't have any questions about this, because we have talked about it, you have read about it, we have had homework checks over it. So if you do have any questions, by all means, be sure to ask me on Friday if you do have a solar eclipse question. Next up we have the lunar eclipse. Now lunar eclipses are a bit more common. This is where the moon is in the Earth's shadow. So with a solar eclipse, it only happens with a new moon. Lunar eclipses only happen with a full moon. So it's the full moon that falls under the Earth's shadow and blocks out the reflected light. Once again, these do happen more common, but still overall not that often. All right, we are going to continue from here. New thing for the day is the seasons. What we need to know about here is the Earth is actually on an axis. So we do have an axis right there. You see it, the north-south pole. And this axis is tilted. Our Earth is not straight up and down. We are at a tilt. So because of that tilt, we get seasons. Weather will change. First question I have for you. Looking at this picture, I want the bottom picture right down there. Spend about 5 seconds, 5 to 10 seconds, talk to your neighbor. I want you to tell me, is the Earth where that arrow is pointed, is the Earth in winter right there? So where that arrow is pointed, is the Earth in winter or is it in summer? 5 seconds, go. All right, you should have your answer by now. Let's see. Are you correct? It is in the summer. Now, how do I know that that's in the summer? Because it's kind of shaded out. Makes me kind of think, oh, it's shaded, it's in the winter. But if you look at this, the way it's tilted, this part of the Earth, so this part of the Earth right down here, is actually closer to the sun. It's tilted towards the sun. The northern hemisphere is tilted away, so this right here is actually a shorter distance if we were to measure it, slightly shorter because of that angle. And because of that, and the angle, it's angled towards the sun now, it is going to be in the summer. So, that should make my next question real easy. If the southern hemisphere is in the summer, What do you think the northern hemisphere is in? 5 seconds, talk to your table, go. And you should have this answer already all set. So, I'm hoping that you came up with the northern hemisphere is in the winter. It is now angled away from the sun ever so slightly. Because of that angling away from the sun, it's going to change the way the rays hit. The sun rays hit. And because of that, we're going to have some cooler temperatures up north. And I'm going to go ahead and show you the rest of the picture. When we want the summer to happen in the northern hemisphere, the Earth has to go all the way around to the other side of the sun. Now the northern hemisphere is tilted, and it is tilted towards the sun. So now, on the next slide, we're going to start talking about how these rays actually are hitting the Earth. All right, so here's our picture. We're going to start with this top picture up here. If we look at the two different lights hitting Earth, this one right here is directly hitting. This one right here is spreading out. So we have one of them that's hitting directly, one of them that's spreading out. Now, if we look right here, this part is the exact same as this part. They're the same size, they're the same amount of energy, they're both just barreling down on the Earth. That's a lot of energy coming in. And at this point, they are the same. It's only when you get right here, that one didn't change, but this one, all that energy spreads out. And when that energy spreads out, it's over a larger space, but the same amount of energy spread out over a larger space, not as much heat on any one given area. All right, so let's talk about that again. So right here, all the energy barrels down and lands right there, so it's all right there. Right here, the same amount of energy, but over a larger space. Since it's over a larger space, it's going to end up being cooler. Same amount of energy, but over more space is going to end up cooling it off. Because of that, when we're around the poles, like the North Pole, South Pole, that's why they stay so cold there. When we are around the equator, it's almost always going to get that very direct sun. That's the reason the equator stays so hot. So if we look down here on the next one, so we see the direct sunlight and we see the angle down here in this picture. Right there you see the flashlight beaming straight down. It's all that light, all that energy on a smaller area right there. So if it's in a smaller area, it gets more energy, and boom, 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 it gets hotter. This one, same amount of energy, but it's spread out over a lot more space. When it's spread out over more space, that energy spreads out. Not any one spot gets as much energy because it has to share, it has to go over a greater space, and therefore it's going to stay cooler. There we go. And we are continuing. So right here, I told you this all has to do with angles, the way the sun, the angle hits the Earth. In the summer, you have a higher angle. That's this top one right here. So we're coming in at a greater angle right here, and we're hitting the Earth. When it comes in at a lower angle, it's going to spread out, and it's going to be over more space. So this one right here is spread out. It's over more space, taking up a lot more of that floor space, if we look at that. Because of that, in the winter, it stays cooler. So in the summer, high angle, more concentration, so that energy is more concentration, higher temperatures. Winter, lower angle, it spreads out over more space. When it spreads out over more space, because if you look at that, this point right here is the same for both of them, but look way back here, that's the other side of the winter one. The summer one stopped right there. So we have almost twice as much space right there in that picture. Because of that, it will stay cooler. And that is the end of the notes for today. Yay, notes! Hopefully you don't have any questions. If you do, by all means, that is what I'm going to be here for on Friday. I will answer all questions. We do have a lab on Friday where we're going to actually experiment and see if we can get some of these same results. All right.